Hello, Algebra 2. Today we're going to do two lessons. I'm going to put them in one video. I'm going to try not to make it too long. 7.3 and 7.4. We're starting with 7.3 and it is power functions and function operations. Sorry, my table moved up. Behind it, it just says these are the four operations for functions. So what we can do is we can add functions together, subtract them, multiply them, and divide them. To add functions, it's just like adding two polynomials. So if f of x is 2x, so here's one function plus another function, you just combine your like terms, then here's your resulting function. Same thing with subtracting, you would want to distribute your minus sign to the second function, subtract them, there you go. Multiplying, you're just multiplying, for instance, two polynomials together, right? In this case we would distribute. And then division, we would divide one by the other, and we'll talk about exactly how to simplify those later. But you can do your four basic operations with functions. We're going to be really concerned about the domain of the resulting function, this h, because our answer here was this h function. And so the domain of h is going to depend on the domain of what f and g were, and also then the domain of the answer. One thing to keep in mind when you're doing your division is you can't divide by 0. So in this case, your domain could not include -1 because -1 would give you 0 on the bottom. You can't divide by 0. We're also going to talk about power functions, and a power function is just a function in the form y equals a times x to the b. Okay, so b is going to be a rational number, so a fraction, but it could also be a whole number because they're also rational numbers. But your exponent is a number. Your x, your variable, is a base. So here we have two functions, f and g, and we want to add them and subtract them. So when you do this, you want to make sure to write them out. So 3x to the 1/3 plus 2x to the 1/3. Well, so if I have 3 of something plus 2 of the same thing, it's probably going to be 5 of those things. So it's just 5x to the 1/3. Their difference, 3x to the 1/3 minus 2x to the 1/3. Make sure you don't switch the order if you're subtracting. So you're going to have 1x to the 1/3. I'm going to leave the domains for us to do in class. So just make sure you've written that part down, and we'll finish the rest of this one in class. Same thing here, we're going to do the product and quotient, then we'll do the domain in class. So the product, I just want to multiply them. So 4x to the 1/3 power times x to the 1/2 power. So you multiply your coefficients together, so it's going to be 4, and then x, and then if I'm multiplying, what do I do with my exponents? I add them. So 1/3 plus 1/2, we got to have a common denominator, that was times 2, and that's times 3, and 5/6. So 4x to the 5/6 power, and it's just the x to the 5/6 power, not the 4. The quotient, we're going to have 4x to the 1/3 divided by x to the 1/2, and we can simplify this. When we are dividing, we subtract our exponents, so 1/3 minus 1/2, and again we're going to have our common denominator, times 2, times 3, subtracting -1/6, so this is going to be 4x to the -1/6, which would be 4 over x to the 1/6. Alright, so make sure you got the adding, subtracting, multiplying, and dividing, and we will do domains together. So our new kind of operation is called the composition of two functions. And the composition of a function with a function is going to look like this. This is f of g of x, meaning typically you'd have f of x, where x is your variable. Now another function is your variable. Okay. These are really actually used fairly common. Let's say you go to the store and there's a sale and you have a coupon. That's a composition when you take these two functions and you're doing them at the same time. And the order in which you do them is really important. So this last step here, need to pay attention to the order. If they do take the sale price first and then your coupon, you might get one price, versus if they do your coupon and then the sale, it might be a completely different price. Go ahead and write down this. The domain of h, which is our new function, is the set of all x values such that x is the domain of g and g of x is the domain of f. Have that written down and I will explain that in class because that's kind of a tough one. To find the domain of h, you actually start with the domain of g, and whatever its domain is, then you apply to f and see what you get as an end domain. And I'll explain that again in class because that's kind of a tricky one. So we want to find the functions. We'll do the first two here. My suggestion is you always rewrite it replacing the middle function. So this is going to be f of x squared minus 1. That is what g of x is. So then I want to evaluate f, which is this first one, and wherever I see an x, I'm going to put all of this. So this is going to be 2 times x squared minus 1 to the negative 1 power. All I did was put that in for x. The negative 1 power is going to drop it down to the bottom, and you can't simplify that. That's what you got. So now for g of f of x, so first of all, I'm going to suggest you replace the f of x in the middle. So it's going to be 2x to the negative 1 is where your f of x was. So then I'm going to evaluate g, and every time I see an x, I'm going to put 2x to the negative 1. So it starts with an x, so it's going to be 2x to the negative 1 squared minus 1, and then we can simplify. This is going to be 4x to the negative 2 minus 1, which is going to be 4 over x squared minus 1. Alright, we'll leave the last two there for class, or you might even try them on your own. That would be a better idea. Okay, so a little intro now to 7.4. 7.4 is called inverse functions. The main thing about an inverse function is it maps the output back to the original input. So, typically, well, if we had a list of ordered pairs, right, x is your input, y is your output, your inverse switches those, and it's going to map 4 back to 1, 5 back to 2, and 6 back to 3. And you actually then would call this your x and your y. You actually switch, and you don't necessarily think about it as y back to x. It switches, and these become your x's. So the range becomes your domain, and the domain becomes your range. Okay, so the x and the y trade places. And the graphs are going to be reflected over the line y equals x. So y equals x is this line, because you're going to go up 1 over 1, you're going through 0. So whatever you had maybe up here gets reflected over that line, and then it's going to come out like that. Right? So every point gets reflected across that line. Alright, so let's look at an example or two. So find the inverse of a line. So the easiest way to do this is you just switch the x and the y. Like technically that's the inverse. That takes all of the ordered pairs on that line and it switches their x's and their y's. You need to go one more step here, and I'd like for you to solve this for y. But I mean, you're just rearranging an equation here. I'm going to divide by negative 3. So y equals negative 1/3 x plus 2. This would be the inverse. Okay, it would be the line that's reflected over that y equals x from our original equation. So if you want to verify that you have the correct inverse, or that two given functions are inverses, you actually do their compositions, which is why we did 7.3 here before 7.4. So you have to do both f of g of x and g of f of x. They should both equal x, and if they do, then the two functions you're using are inverses of each other. And sometimes instead of g, you'll see f to the negative first power. That means f inverse. That is red f inverse. And so f and f inverse, those are inverses of each other. But we want to verify, so let's verify here real quick. So here it says verify that f and f inverse are inverses. Okay, so they should be. Alright, so first of all, we're going to verify f of f inverse of x. And so our composition, remember I said you really want to replace that inside function. So we're going to place it with negative 1/3 x plus 2. And then we're going to evaluate f. So negative 3 times x, which is negative 1/3 x plus 2, plus 6. And you're going to simplify. So we'll distribute. So negative 3 times negative 1/3 is just x minus 6 plus 6, which is just x. That's what you're after at the end. But just because that one worked doesn't mean the other one will work. So f inverse of f of x. Okay, again, replace that inside function. So we're going to replace it with negative 3x plus 6. So then we're going to evaluate f inverse, which is negative 1/3 times x, which is going to be negative 3x plus 6, plus 2. Negative 1/3 times negative 3, that's a positive 1x, minus a third of 2 is, or sorry, a third of 6 is 2, but it's negative minus 2 plus 2, which is just x. Alright, hopefully some of that made sense to you. We'll clarify anything in class. Let me know if you have questions. Have a good day. We'll see you in class.